Hello, today we are going to take a look at two AP multiple choice questions. They're both going to have to do about reading tables. So first of all, the function f is continuous on the closed interval from 2 to 4 and twice differentiable on the open interval 2 to 4. That just means you can find the second derivative. So if f prime of 3 equals 2 and f double prime of x is less than 0, which could be a table of values for the original function. Alright, so if f prime of 3 is equal to 2, that means the slope at 3 is 2. If we have f double prime of x is less than 0, that means it's concave down. And what does concave down also mean? That means the slope is decreasing. So it can still be a positive slope, but the slope is slowing down. In fact, that's the thing we want to focus on first, the fact that the slope is decreasing. That means as I go along from 2 to 3 to 4, the rate of change in between 2 and 3 has to be more than between 3 and 4. Okay, then the slope would be decreasing. And when I do the slope here, I can just do like the normal slope, the average rate of change, the secant line slope. So you're going to be doing things like 5 minus 2.5 over 3 minus 2. Well, that gives me a slope of 2.5. And then on the next one, I go 6.5 minus 5 over 4 minus 3, which equals 1.5. So I see that slope is decreasing there, so A is okay. Now in all of these, that x steps by 1. So really the slope is just 5 minus 2.5, 7 minus 5. So in this case, the slope is 2.5. Here the slope is 2. Okay, the slope is decreasing, so it could be B. And the next one, the slope is 2, and now the slope is 1.5. Again, the slope is decreasing, so we can keep that guy in. But here, slope is 2, slope is 2. That is not decreasing. That slope is staying constant. Okay, so it cannot be D. And then in E, we have 1.5 and then 2.5, clearly increasing. So we don't want that guy. So now, the next thing we want to look at is the combination of the fact that at 3, the slope is 2, yet it still must be decreasing as we kind of go through x equals 3. When we take a look at C right here, notice how the slope between 2 and 3 is already at 2. And then after 3, it goes down to 1.5. Well, that means if the slope somewhere here between 2 and 3 is already at 2, that means when I get to 3, like it has to be decreasing. That means when I'm at 3, the slope actually has to be like 1.9 or something. Because of the fact that the slope is, the concavity is concave down, the slope has to continue decreasing. So if it already reaches a slope of 2, somewhere between 2 and 3, when it is actually at 3, f prime of 3 cannot equal 2. And that takes away C from us. And in fact, that same line of thinking can be applied for B, but kind of opposite way. In this case, I'm at 2.5 here and 2 between 4 and 3. So in this case, sure, I'm at slope of 2.5 somewhere between 2 and 3, which means when I get to 3, I could have a slope of 2, but if it needs to keep decreasing because it's concave down, I can't have a slope of 2 somewhere between 3 and 4. Okay, because it has to reach 2. At 3, it has to have a slope of 2. And then it has to continue decreasing, which means somewhere between 1 and 3, it has to be at least like 1.9 or something like that. So because of the fact that it's concave down, you also eliminate B, which leaves us only with A, and let's see if this makes sense. For A here, the slope is 2.5 between it, and then 1.5 between 3 and 4, which sure means it could be decreasing before 3. It could hit 2 at 3 and then keep decreasing, and it would be fine. So our answer in this case is A. Alright, another table question. This table gives selected values for the velocity of a particle moving along the x-axis. The particle is at the origin to start. Which of the following could be the graph of the position function from 0 to 4 seconds? Remember that velocity is the derivative of the position function. So that means when I'm looking at this chart up top, this table, when I see v of t equal -1, that means my velocity is decreasing. I have a negative velocity. That means my object is going backwards. So the first thing we want to look at the start, the object has to begin going backwards, which means it's going to have a negative position. Because if it starts at the origin and you immediately start going backwards, so if you start at 0 and you go backwards, you're going to have a negative distance. Okay, so that means it's going to be below the x-axis. That immediately helps us eliminate A and B. B is already off the bat because it does not start at the origin. And D is also out because it does not start at the origin. So I'm already down to C and E. Another interesting thing to look at with this is where the velocity is 0. So on these type of questions, look for those outlier points. 0 is a great place. Look for if there's a 0 in the chart, because that might mean something important, something easy to look for. Since the velocity is 0 at t equals 3, that means at t equals 3, my particle must be standing still because its velocity is 0. So that means I have a horizontal tangent line at t equals 3. It can't be moving forwards or backwards. Okay, so that keeps both C and E in the plane field. For C, it looks very close if C is actually a horizontal tangent line, but it looks to barely sneak in. But we would still like to clarify. We would want one more idea to confirm this. So we look at t equals 1. The velocity is 2, which means the particle is going forward. So it isn't going up the y-axis, it is increasing. So if I go to t equals 1, right here the particle is in fact going up, but here the particle is standing still. Okay, it's got a horizontal tangent line there. So that is out of the game, leaving us just C as our answer.